So I think the next logical step is to create some type of container class for the points, which we can use for the moment to calculate and display relevant information, like radius of circles and stuff, just so we can get an idea of the program. And later this will be used to calculate the required information, store it in a nice place, and then do the correct, do the optimizations and stuff needed, the calculations needed to produce the curved path. So, and then output it afterwards. Not only output it, but also like display it before we even get to the point where we start outputting it and constructing like the individual dot points. It will help us display like the tangent optimization and stuff like that. So let's get started on that. Alright, so I've added the class called pathCurver, and I've added a new variable radius. This just controls the global radius of the curving circles for the moment. I'll probably modify that later, or at least I'll make sure to take that you can have multiple different radius among curves. In theory at least. I probably won't use that in this program, but it will become useful later when we want to start tweaking around. So for the moment we just have one global radius. At the bottom you can see I've created, well, one thing is that I've created a bunch of methods for points, including square magnitude, regular magnitude, finding the normal of a point. In hindsight maybe I didn't need all this, but I added it anyway. I added a bunch of other stuff: add, scale, difference, cross product, dot product. A second cross product for taking the cross product of a float and a point, the float being generated by an original cross product, perhaps, so that it can rotate it basically. But I might not actually end up using these functions depending on how it goes, because originally I wanted to use cross products to help figure out which side the tangent should be on, but I'm beginning to think that perhaps I could do that just using the average of difference, the average of 2 points, normalized stuff as things move around, if that makes any sense. Basically, when I change from the original path to the modified path, I treat the original path as my initial assumption for the end of the tangent lines, and then I optimize from there. And I think that should actually work pretty well. I'm not sure yet if it will work 100% of the time, and that's part of the reason I thought about the cross products. But maybe I was wrong. Maybe the cross products are actually the ones that won't work 100% of the time. So I'll think about it, and as I have a HUD, it should work fine. Then I created the pathCurver, so it takes a reference list of points, but it also has an internal representation separate of the list of points as a built-in array, as opposed to an array list. I also have a list of path differences. I have a list of cross products, which takes the cross products of each of the path differences to figure out the curvature at a particular point, at particular points, except for the first and last one, obviously. And also a list of radii. But this is empty at the moment because we haven't got different curves. So you can see when it's created, it takes a reference and then performs the update operation immediately. The update operation basically updates the internal representation using the reference, which is the one we create. So at the moment this update is called every frame in order to draw, but in the final version it should only be called like when you want to do the computation. And it creates the path differences. I also had it creating cross products, but since I probably won't use them in hindsight, I commented that out for the moment. And then finally draw, which at the moment doesn't really do much, but it gives us a bit of, but it's a drawing on top of this class that basically shows us the radius and the curvature. So if I click now, you see if I have 1 point, nothing much happens. If I have 2 points, nothing much happens. But once I add a third, I've also decreased the line thickness. Once I add a third point, it starts showing the curviness, where it starts showing the circle that the path is going to wrap around. Now at this point I have two choices. I can either start trying to optimize tangents now and then try and make the modified path, or I can try to find the modified path now and then show the modified path and the moved circles with the regular path and see how that works. And I think I'm going to do that. So the next thing I'm going to do is code the modified path in and change this HUD representation around again. Alright, so I've added the modified path. You can't see it yet, but I've added the modified path and I've changed it so that the circles now go around the modified path. So the result is as follows. After 2 clicks, not much, but the third click, we have the circle now, the correct mass is applied, the circle goes around the hidden modified path, and you can see it now curves around through the correct point and in the correct direction, and we can see how that works pretty well. Oh, maybe it doesn't work quite as well. Food for thought. Just a second. No, it shouldn't work like this. I need to make sure I normalize the average array things before Oh, that's tough. Alright, let me try something and I'll see if it works. Well, actually I haven't tried it yet, but basically the issue is, see, if I have a long vector here, and then a relatively short vector, you see the circle basically points along the long vector, whereas I think at least, that really it should be, well, I mean, you know, I can't really say what should be for sure, but basically I don't really want that, I think, because the problem is the average is biased in favor of the long vector, and I don't know if I really want that. I would much prefer, I think, for it to be in the middle. So yeah. So the way I'm going to try and do that is I'm going to try and add some normalization before I do the calculations. So right here where I do my calculations, it turns out it's a bit more complicated than just averaging it and normalizing, because you actually have to average and stuff and normalize the difference, and then you have to add that difference back onto the path. So no, you got to take the difference. Anyway, that's not the point. Problem solved. You can see now, doesn't matter how I do it, it always does it in the correct direction. Now, that's what I want. I don't quite know yet, but it definitely always makes the same shape now, which is pretty cool. Although I wonder if this radius is a bit big for the current project. So I'm going to change it, make it smaller. I'm going to make it about 25. So yeah, pretty cool. So I'm going to see, maybe I could use a different HUD, but this seems to be going pretty well for the moment. Just a quick comparison between with and without normalization on the small version. So here is a pentagon, and a square with normalization, without normalization. One of the important things to notice how on the square it kind of actually makes a quite nice square-like shape, which might actually be beneficial. You can see that this isn't quite the case for bigger squares, except rectangles. You see it prioritizes the short paths, right? But if I switch to using normalization, then it's a bit different, right? So I'm going to try and recreate that path, although I don't quite remember how exactly it went. You can see that the circles, well, I'll try and make a long path here. Well, I guess it kind of does the same thing, so maybe it's not so bad after all. One of the other things is, like, yeah, when you do the straight lines, it picks a side. So actually it's kind of good for straight lines. So definitely sticking with normalization.